Okay, I'm gonna go ahead and get started. We got some interesting content. It's definitely dense, like a lot of the things I'm sure you're seeing at reInvent. So I want you to get as much out of this as possible. It's called Deploying and Managing .NET Pipelines and Microsoft Workloads. My name's Tom Fuller. I'm a solution architect out of Atlanta, Georgia. I actually worked at Microsoft for 6 years. Now I've been at Amazon for 2.5. I've been a .NET developer for 15 plus. So show of hands, how many of you are .NET developers? You're here to this session because holy moly, awesome, cool. PowerShell, operational scripting, right? I mean, maybe it's the same hands, but very cool. You're gonna see some cool things here. There's gonna be takeaways. You're gonna learn about, the services from AWS that you can use to actually deploy and automate. So, what should you expect? Best practices, tips, tricks, things we've learned by working with customers that are doing .NET development, working with customers that are using our CodeStar services and operating and managing things at scale. We're going to show you an actual Windows-specific quick start, and you're going to learn a lot about this quick start concept. I'm a huge believer in the idea that Amazon has all the building blocks, but at times can be challenging to pull them together in a sort of cohesive manner to solve a solution. Quick Starts helps us fill some of that for customers in specific different ways, whether it be big data. We're going to look at Microsoft workloads. And then we're going to hear from Woot. And Woot's in the Amazon family. If you haven't heard of Woot, Theo's going to tell you all about it. And they've been doing some really cool stuff with Windows workloads. They've taken a journey from the early phases of moving into AWS, and now it's how do they actually do these things at scale and how they're evolving. So disclaimer. Best practices can be subjective. Happy to have conversations with any of you that would like to try to suggest that some of them should be done in a different way. We may not argue at all. There may be different criteria. There could be all kinds of reasons why some of the things we're describing aren't necessarily perfect in your environment or your scenario. But what we're trying to give you is building blocks and automation, goodies and things that can make your life better. Easy can be relative. So it has certainly taken some effort to get these things in a state where you can consume them and learn from them. Let's just keep our minds open. And then the last one is innovations are not frozen in time. So things change, right? There'll be new ways some of this stuff is developed and new ways in which you can bring things and actually deploy things. Next year, maybe this session has a whole different twist and some other avenues that you can explore. This one always plays well with .NET developers, so I'll just pause and let you read it. I really think my favorite part about this is that it was marked as answered. All right. So if you were in my session last year, I actually took a little bit of a different tact. I kind of covered, like at a 200 level, all the different services that had a Windows story from a DevOps perspective. It included, talking about Beanstalk, talking about CodeDeploy, talking about OpsWorks, talking about all the things that you could do with Windows. This is a little different, but I still wanted to take a quick moment to cover the fact that these things continue to evolve and continue to add new features and continue to be very useful in their own right. So the SDK for .NET, if you're looking at .NET Core and you're seeing where Microsoft's headed with .NET, we've stayed on pace with that. Right? We have capabilities that are being added to the SDK to deal with some of the issues with the configuration manager and all the things that, if you're really going to want to be an early adopter on .NET Core and you still are going to target AWS services, our SDK is prepared to help you. Visual Studio, obviously, awesome, popular IDE for developers. And the tools from Windows PowerShell. So as the APIs continue to release and drop, the PowerShell commandlets need to support you so that you don't have to go necessarily directly against these APIs with REST calls. And then there's the higher level services, and I'll just highlight a couple of things that have come out. If you haven't noticed, SQL Server can be done via domain join. You can do integrated security across your application tier to your database tier as a long sought after feature. Beanstalk can support multiple .NET applications being all deployed in a single package. And then you've got things like Simple Systems Manager that helps you, and by the way, right, that came out last year at reInvent, and that was targeting Windows first. It has since evolved to also include Linux, so it's a consistent manner in which you can remotely manage fleets of any size with PowerShell scripts and shell scripts and all the things that you may need. And Theo will talk a bit more about that. So now I'm going to introduce you to Santiago. Santiago is going to talk about quick starts. And what I did last year is there was a demo that I gave, and it was a little bit more of a manual. You're in the IDE, you're writing .NET code, you click a button, and it goes up, but you still kind of went to GitHub, and quite frankly, it was a little clunky by comparison to what I had seen other colleagues of mine build, where they could click a button and code pipelines. So Santiago was sort of my Yoda of helping me figure out how to do this stuff in a packageable way so that you guys can all go out, download it, and start playing with it. How did he do that? Like, I'm going to let him share that with you.
All right. Can everybody hear me okay? So my name is Santiago Cardenas. Thank you, Tom, for the introduction there. What I'm going to do here is give you a little bit of tips and tricks that we've seen on some Windows-based quick starts that we've released. And we'll go over some examples and whatnot. Some of you may be wondering, what are quick starts? Quick starts are basically automated reference architecture deployments on AWS. So what they are, they're basically all these different assets, from a white paper style deployment guide to all these automation assets like scripts, CloudFormation templates, and whatnot. We also have some community quick starts that are we actually jointly develop with some partners. So those are also available for everybody to use as well. We're a distributed team across 3 different sites. We cover the globe in terms of partners. We're part of the AWS Partner Program, so we're very close. We work closely together with AWS partners to create a lot of these different reference architectures. And you can visit us at aws.amazon.com/quickstart. Specifically in this particular session, we're going to talk about some of the Windows-based tips and tricks. So we have quite a few Windows-based AWS quick starts, from Active Directory domain services to SharePoint server, remote desktop gateway, and Tom will talk a little bit about the CI/CD for Windows later on. So as we've developed a lot of these quick starts, we've seen some recurring themes. We've seen a lot of orchestration of how we deploy and these different AWS services and deploy and configure all these resources. We've seen a lot of scripting. In the Windows world, it's mostly PowerShell. And then we do a lot of source control as well to kind of complete that infrastructure as code story to get some, capture the revision history and version control. So AWS CloudFormation, it gives you give developers a kind of declarative way to create resources and manage them. It also understands these different implicit or explicit dependencies that you may have between resources. You can create reusable components as well. So you can, I'll talk about some of the reusability pieces of it on some examples that we've done for Windows. You can write it in JSON or now in YAML as well. And the authoring tools that we provide, and also some ones that are from the community, have started to improve quite a bit. So it's very easy now. There's a lot of error checking that happens as you write them. Some of the tips and tricks that we've done is the way we source files in relative paths within CloudFormation templates for quick starts is we create all these assets separately, all these scripts. We don't actually we try not to embed them within the actual CloudFormation template because it becomes a little cumbersome to debug and develop. So what we do is we actually pull them in, and the way we pull them in into the particular stack is we use these relative paths where we actually join using a /, and we figure out the quick start. So we have a map where we have wherever the quick start S3 bucket is located. You find this at the top of the template itself. Then we have a parameter that we pass in as the bucket name where the quick start assets are located. Then we have a key prefix where we would store the different quick start assets for a particular quick start. And then we have a relative path there of the actual asset that we want to pull in. So we're pulling this install ADFS PS1 script, and we're going to put it in the location that's at the top, which is in CCFN scripts, install ADFS. In terms of nested CloudFormation stacks, so in terms of you want to make some reusable building blocks, and a lot of the Microsoft deployments will depend on an AD stack, for example. But before you deploy an AD stack, you need all the networking in place, so you typically use a VPC for. So what we do is using nested CloudFormation stacks, you would declare kind of your base networking infrastructure by calling a VPC stack, In there, we call a separate template, CloudFormation template, that we have as part of the quick start assets, and all the parameters that need to be pushed into that to that stack. And then we call, for example, the AD stack after that. The AD stack will actually use some of the outputs that come from the VPC stack and use them in itself. So another alternative to this kind of workflow is to use exports and then use imports as well if you want separate stacks. Because the quick starts are actually kind of packaged together as a group of assets, we actually nest them all together. And then from there on, you can have many other stacks, maybe a SharePoint stack, a SQL Server stack, and you can kind of pick and choose depending on the environment. Then after you kind of have all these resources in place through CloudFormation, all these AWS resources and services, the last mile really here now is the bootstrapping. So in the Windows world, it's mostly PowerShell. And that's really what we try to use at all times in Windows, because kind of a first-class citizens in the Windows world. There are some challenges also of how things like reboots, service restarts, some of the different security models that you have to kind of accomplish with your bootstrapping. I mean, I'll have some examples of that. And the techniques that you use here will actually kind of make or break your approach. You need to be able to catch some of the exceptions, be able to bubble up these errors, so the stack kind of halts in case there's any trouble. As we were developing some of these scripts for bootstrapping, we saw there was some common patterns on some of the things that we were doing across multiple Windows-based quick starts. So we kind of split them into a module and then some scripts. These all get pulled in. So if you see the link at the bottom, we have them available, and they're just different utilities that we kind of see across the different Microsoft-based quick starts. Things like downloading a file, creating a share, joining a domain. All these things that were kind of common across quick starts, we actually reuse them. And for a PowerShell module, we had a lot of operations that we did in terms of creating a wait handle, storing it, and then basically signaling at the end whether there was an issue. So we would actually signal with an exception, or if if we were successful, we would signal with just to signal back the status to the CloudFormation stack. The sample PowerShell script that we create, most of our PowerShell scripts kind of look like this, a kind of top-down approach there. We'll have some parameters. Then we'll have a try-catch block. In a try block, we always set the error action preference to stop, so we catch any non-terminated errors. That way we can signal on those errors in case they cause any issues down the road. And then we do any stuff that we need to do as part of this configuration. It could be installing an application, starting up a service, whatever it is we need to do. If there's any issue that comes up, we catch it in the catch block, and then we pass it to one of the command lists that we created in the module that I showed earlier, where basically we do a few things like signaling CloudFormation with the error, and then we also write a Windows event on this as well. Ideally, longer term, you'd actually want to use some configuration management. This ensures that you can rerun your scripts in place. It also ensures that you can basically, if you need to make sure something's configured and in place at all times, if somebody makes a change and it kind of sets it back to where it's supposed to be, you should really look into some of these configuration management tools. PowerShell DSC obviously is kind of, again, first-class citizen on the Windows world, so a lot of people actually try to use that. We also have some great partner solutions, so you can create like Ansible playbooks, chef recipes, or Puppet manifests. In terms of invoking the PowerShell scripts within the CloudFormation templates, what we do is we, inside a CFN init section block, inside the commands, we will actually call PowerShell, set the command, and that command we basically pass a script that we've downloaded earlier from some of those relative paths that I talked about earlier. And that way we can just execute the script. After that script is done, and it moves on to the next step that we have there specified in the CFN init metadata. In terms of handling Windows reboots, so these are very common on Windows. Whenever you install a large piece of software that affects a driver or whatnot, you'd have to do a reboot. So the way we handle this is very similar. We call a PowerShell exe, again with a command. We pass a script that's going to have a reboot operation within it. In this case, we actually pass a switch parameter to restart. So within the script, we actually call a restart. And we actually, in this case, we also use a parameter as well that gets passed in from a higher level in the template. And then we close in everything with quotes. Very important thing to do in some of this stuff is to make sure you encapsulate everything with quotes. A lot of times when you have these special characters, PowerShell will pick them up and think it's something else. So you make sure we close it up. And then at the end, we set this particular property, wait after completion forever. So what that does is when the actual script triggers the restart on the operating system on Windows, it'll actually pause all of the CFN init execution. It'll restart. It'll wait until it comes back up, all the servers are up and running, and it'll resume from the point it left off. So it goes actually to the next step. So you don't go and rerun everything and whatnot. After you do all the operations that you have to do for a particular stack, you want to make sure you signal back. This helps you also with all of these dependencies between services or files that you have to have in place, applications that you have to install and whatnot. So basically you would, in this example, this is kind of similar to what we had before in the last slide. We'd have something that does a reboot. So it'll do a wave after completion forever. Let's say this is towards the end of our particular CloudFormation stack. It'll wait until the service, the actual instance comes back up and it's online. And then it'll execute the next step in CloudFormation in Cloud Init, sorry. And what we'll do is we'll actually just call PowerShell exe, and we call one of the command lists that we have on our AWS Quick Start module, and that'll go ahead and signal up to CloudFormation. This is basically the approach that we do for scenarios that are more complex that have reboots in between. The reason why we use this and not user data, just to remind you guys, in user data, if you were to put the signal right at the end, if the server reboots, user data does not execute again. So that's the reason why we use in the Windows world, we try to use CFN init as much as possible. As part of the AWS Quick Start program, we also try to reuse code a lot, and we try to share it with customers as well. So all of our Quick Starts are actually open source. They're licensed under Apache 2.0, and they're available at AWS Quick Start organization within GitHub. What we do as well with a lot of the building block kind of quick starts, things like we have a VPC quick start, that's a kind of a building block, RD gateway. As you can see there on the right, we actually, we'll reference them as sub-modules and kind of keep a snapshot of it within a particular quick start so we can package all the assets together for a particular quick start at a particular version and release that. As part of some continuous integration and continuous delivery that we do, we have some systems that monitor the GitHub branches whenever a change goes into the develop branch. We tested in all the supported regions for that particular quick start, and if everything goes well, we also update all the AMIs that may have changed. As you know, from time to time, we update the Windows AMIs, and when new ones are released, a few months back, we deprecate the old ones. So we go ahead and make sure that we keep them up to date, all these different quick starts. Then if all the tests pass, we merge all the code changes to the master branch, and then we copy all the artifacts. We don't have any compilation that happens here. We just collect all the artifacts that are part of the repository, and we just copy them to S3, to a production S3 bucket where customers can launch from. So with that, I'll pass it back to Tom, who will talk a little bit more about the CI/CD quick start.
All right, cool stuff, right? I mean, I think walking in the door alone, I've talked to a lot of customers, they don't recognize all that PowerShell stuff that's already been written and is available out for download that you can use for rebooting the machine and coordinating all the different activities. And they've figured it out by battle testing it across SharePoint and SQL Server and pretty complicated multi-server workloads. So then, the story kind of goes, I did this thing with .NET because that's my background. I wanted to use CodeDeploy, but then sort of felt like it really wasn't reusable for anybody. Last year at reInvent, there was a demo application that I let folks kind of take and actually use to actually see how the full process would work end to end. So I think it was early in the summer, I reached out and started talking to Santiago about, what's the right way to bring this material to customers so they can figure out. 50-page white paper? Probably not. Let's look at a way that we can automate it. Let's look at a way that it can be something that you can either learn from by taking the demo application, deploying it out there, seeing a full pipeline run end to end, or actually just sort of bring your own code and actually run it through. So what I want to show you now is what's actually available. It launched on November 7th, so it's fresh, right? It's actually been worked on for quite a bit. We've done a lot of work testing it, making sure it works in all the various regions. We had some fun in Ohio when we were launching that. So let's talk about pipelines, make sure we're all on the same page with this whole CI/CD thing. You know, these terms get thrown around a lot. Here's the way we think about them at AWS. Continuous integration is getting everything up into a test environment. Continuous delivery will take it all the way through to production, but with potentially, you know, gates, ways in which people are making decisions manually so things aren't flowing every time you run a check-in. And then there's continuous deployment, which is, you know, the kind of thing that you might be doing if you can just bring every code check-in that goes through full automated test pipelines and pushes it directly into a production environment. Now, pipelines, this isn't a unique .NET concept, a Windows concept, it's universal. The idea is a pipeline can, you know, get something consistently through in a repeatable fashion. Over time, it can help you scale, it can help you get velocity, it can do a lot of the things that you are hoping to see when you're looking for custom code development to just get better, get easier. So faster, simpler. And we built a service, and this service hasn't been around for a long time. It's a relatively new service on the scene. It's called AWS Code Pipeline. It is able to do a lot of different interesting things. It integrates well with the services from AWS, other CodeStar services, whether it be Code Pipeline, whether it be, Code Pipeline integrates with Code Pipeline, FYI. CodeDeploy, it actually does quite a good job looking at things like Beanstalk as a deployment target. And then there's a full extensible model, and you see these logos at the bottom. You see GitHub, you see Jenkins, TeamCity, and what's really cool is that there's a framework there to build custom actions that lets you plug directly into that pipeline, and you're going to see that today. The different things you can do are kind of infinite if you think about it. Lambda is another example, something that can plug into your code pipeline. So you could write your own custom notification engine on the backside. Think about the continuous delivery model where somebody needs to go in and check and actually approve a change before it moves any further down a pipeline. And the pipelines are kind of your own open orchestration workflow where you can go parallel and do things, you know, either it's serial fashion or sequentially. There's lots of different cool things possible. So Jenkins and MS Build kind of took an interesting approach here. We did want to bring this to everybody and keep it low cost, keep it easy to integrate and automate, and Jenkins fit the bill for a number of different reasons. And you'll see it. I'm going to actually show you some of the code here, some of the bootstrapping, what it took to actually get this up and running with MS Build as an option, what it took to get this up and running and talk to the code pipeline so that it could pull in a new release. What it took for me to actually get it running with a user account that you predefine in the CloudFormation template and create that on the actual Jenkins instance. There are a lot of things you can do with this. You can go a lot further with Jenkins. If you're not familiar with it, it's got the ability to hook into an LDAP repository, so you could go you can go to a distributed configuration. The thought here with this is you would do it for a specific application and you could have multiple deployments of Jenkins. If you wanted to centralize it, it's certainly an option. You'd have to kind of do a little bit of work with the quick start to do that. One more thing, CodeDeploy. We'll highlight CodeDeploy again. And we've had some conversations about CodeDeploy versus Beanstalk as sort of how we evolved the quick start. But CodeDeploy was, quite frankly, what I used last year. And it runs on Windows, it runs on premises, it has a lot of strong capabilities for .NET developers, so I stuck with it. And it's available, and that's kind of what you have by default. Integrates well with third-party tools, obviously can deploy through to EC2 very easily. So this is what it looks like at a high level. I'm not going to spend a ton of time showing it to you here. I actually want to get in and show you the bits and bytes and actually run a full demo. I've got a recorded version, but I kind of like to run wild, so we're going to actually do it live. Seems like the internet's holding up. Everybody turn off their Wi-Fi. All right, I got to switch, right? All right. Okay, first and foremost, where do you get these things? Santiago mentioned the quick start URL, which you can probably not see right there because it's super tiny, but this is the CI/CD pipeline underneath the DevOps category, but you know, here's your Microsoft workloads. If you wanted to run and stand up a link server, if you want to run and stand up an Exchange server, no bueno. And we're back. SAP workloads, MongoDB, very popular, different big data solutions, and just keep checking back in there. This is not, the Quick Start team is doing amazing work at helping bring this stuff to market. So the CI/CD pipeline, how would I launch it? You can view a deployment guide if you want to really dig into understanding it first. This is fabulous, huh? Wiggle, 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 wiggle. All right. All right, so let's go ahead and deploy one. And what happens when you deploy one? It's a CloudFormation template. We've defaulted it to the US West region, but you can run anywhere Code Pipeline can run, you can run it. That's kind of the follower right now as far as getting available, but it's just recently launched in a couple of other regions. I don't think you'll see a ton of problems as far as regions that you may want to run in. It comes right down here in the bottom, and you'll see there's my template. So the template itself you can go and run, but I want to first show you some of the parameterization that exists, some of the things that we are automating. Obviously, you pick availability zones within a given region, and why is that? Well, this is actually going to deploy a load balancer. It's going to deploy multiple instances. Why would you want that? Well, what if you wanted to test rolling an upgraded change through? Now, I really consider this more of a CI solution initially, because we had to do some kind of things to make it friendly for development and test purposes, like creating self-signed certificates. That's probably not going to be something you would use in production necessarily. I wanted to be able to give you a way to do a multi-server configuration and do load balancer testing, but not necessarily go to 50 instances in an auto-scaling group. Like, those are the kinds of things you may want to enhance in the quick start if you're thinking about it for all the way through to continuous delivery into a production environment. So one of the things, and I don't know if it was obvious to everyone in the room, but the quick starts are composable based off of how they've been refactored. So think of it just like an object-oriented design mindset. I've got a VPC, I need that, and I'm going to reuse that by extending it. I'm going to embrace it, I'm going to extend it. You can also overwrite it. There's a lot of those types of concepts in here, and it seems kind of odd to say it's JSON or YAML, but you can actually come up with a nice reusable technique, and that's what the Quick Start team brought. So, set up your VPC. It's the same way the VPC is set up for other environments. I set up remote gateways. So you're able to set up and connect to it remotely across different availability zones. So if you needed to get on the instance, quite frankly, you don't have to do this. One of the recommendations I make in the deployment guide is set it all up, turn them off. Right? Those jump boxes don't need to be sitting there active. They're running the meter on you. But if you need to go in there and deploy something and troubleshoot it and get on the instance, it's a reality of life. So then we start getting into some of the more specific parameters that are related to either deploying a demo application or using it with your own code that you want to bring. So you can see there's some pretty deep instruction here, and that's because it was a unique approach, right? It was let's make this a training tool as much as it is sort of a starter, quick start for you to go out and build your own CI/CD pipeline and bring your own code. If you choose true, we're going to drop a zip file out there in an S3 bucket that we generate that you can then go click a button in Code Pipeline and make changes to the code and just watch the flow of execution. You can use it for demo purposes. You can use it for a lot of different things. But if you choose false, then this bad boy kicks in, which is what exactly is the code package that you're bringing to us in the S3 bucket, and then we'll extract it and we'll set it up on that server, and now you're basically using it as though it's something that you're integrating with. For example, what if you did something like S3 is the output of your build, your on-premises source repository, right? You could do that kind of full integration in a hybrid sense. Lots of options here. Coming down to the bottom, Jenkins. And this is where we start doing things like creating SSL self-signed certificates. This is where we create the custom actions. This is where we create a unique Jenkins user. And you give us a little information about how to path through that zip file to find the CS proj. And it's either an SLN or a CS proj for all the .NET developers in the room. That's typically a couple thousand lines of stuff that's kind of spewed out of Visual Studio. Basically, we customize that so that we know where the source code is and where you want to drop release binaries so that we can convoy it up in via CodeDeploy. So those are the parameters. Now let's go take a look at some of the actual source that's there. This is that master template. Just want to take a quick second on this because this is where you get that power of reuse. There's the VPC stack, the remote gateway stack, and then here's the custom CI/CD stack that was extending those previously already written and tested VPC and remote gateways. This could be applicable to your own environment from a CloudFormation perspective. Then we get into the meat. And if you've done work with CloudFormation, you kind of know some of this already, but what we really needed to do is figure out how to integrate all of the different pieces of Jenkins and MS Build, and there's different custom files. And so one of the files I wanted to highlight is this Groovy file. So this is a plugin that gets put into Jenkins, and it allows you to run this Java code. This Java code is an API call against the local environment to create a user account. So I'm running that through the bootstrapping so that you don't have to do wonky things like make it publicly available at the beginning or any of the kind of poor security posturing that sometimes you see when you're kind of getting through bootstrapping challenges. So that's a good example. Here's another one, and this one's a little bit harder on the eyes, but this is a job in Jenkins. This is actually your code application. This is the Jenkins custom action version number, the region that we're running in. It's all the things that you need in Jenkins to hook up to code pipeline, hook up to MS Build, and be able to do a release. Through tap. Okay. All right. Now those are a couple of files that are generated, and then let's look just briefly at some of the stuff that's done. And if you remember those standards that Santiago was talking about, he was talking about all the different steps that we go through. So obviously PowerShell set the execution policy, get the quick start module started, and then the signaling at the end. But then there's all these steps in between, creating certificates so we can do SSL, Bouncy Castle. If you're familiar with that, that's how the self-signed certificates are created. Again, a nice open source library that you can download dynamically and use. If you've gone out and researched how to do self-signed certificates on Windows platform, you've probably seen things like OpenSSL, running different kind of tooling to convert PEM files from PFX files and all that, right? So this actually fully integrates all of that, so you could use that just by itself. Now, the stuff that gets really interesting is right here. And it's not really interesting from a bootstrapping perspective. And this is one of those areas where Santiago really steered me straight. Because I had written a lot of this in the user data scripts. But PowerShell gives you true try-catch semantics. So I can actually get a try-catch block set up, and I can see what may have gone right or wrong as I flow through this bootstrapping logic. And some of this stuff is trivial. Some of the stuff is start an MSI or an EXE to install MS Build. Right? Some of this is, copy these what are called HPI files, which are Jenkins plugins, and then run a restart. Like these aren't super complicated steps. But then we start getting down here, and this is another interesting factor of how I felt Jenkins was much easier to automate. We got a full jar file that can run a CLI locally. It's a little distracting, huh? Sorry. All right, we'll get through this. You can see there's a local host API we can call that's created when Jenkins is generated, when Jenkins is stood up, and then that's how I run that Groovy script. So if you remember that file that was generated at the beginning, well, there's that bad boy right here, and that's how that user is created dynamically through the parameters you gave CloudFormation. Then if we go a little further down, here's how the Jenkins job itself is created. And remember, folks, all this is open source, all this is available to download, tweak it, tune it, whatever really makes sense for you. But these kind of get you all the way through to be able to test it. And we'll actually kick off a test here in a minute so you can see it run end to end. I do want to show the actual Bouncy Castle libraries that were incorporated so that you can see how we are able to create certificates and upload them through our own API. Again, using the PowerShell commandlets that are natively available on the Windows instances. So last thing before we move forward, I wanted to make sure you understand, this demo application. And this demo application, I handcrafted this CS project file so that it actually could showcase how to use things like ASP.NET pre-compilation. It could showcase how you could do a release copy, so that the files that you're actually deploying to the servers are only the binaries, not the full source code. It's a little bit more of a realistic scenario. Check. The thing that's important to really understand is these two custom parameters, because I feed those in from Jenkins so that you know where the source code is and you know where the release folder is, and then this is how the copying of the file data actually occurs, and this is all visible within Jenkins when we start kicking all this stuff off. Okay, so now coming back through, let's look at the actual setup inside of AWS. So I'm not going to actually deploy this. If you're interested, it takes about 30 minutes to deploy from scratch. And it'll create, again, it depends on the number of instances you select, but roughly 30 minutes to deploy everything. We're not going to do that here, obviously. Everything has already been pre-deployed, so I'm doing the whole cooking show thing. What I want to show you is, as the assets are deployed, we're able to deploy new code changes. So I'm going to go into Visual Studio Code, running on my Mac, and I'm going to make a change to this code right here. Now this is the same type of a solution I wrote last year to demonstrate, simple back-end code build changes. And it's my soccer team. My hardest thing I do every week is coach my 9-year-old girls' soccer team. And I had to make a choice. I had to make a hard choice. Only a few of them could make the all-star team. So one of those wasn't my daughter, and I got in trouble. So I need to go in and make a code change here, and I'm going to redeploy. So you can see right now, the logic says, unless you've gotten more than 10 goals, you didn't make the team. So I'm going to go back in, and in Visual Studio Code, I'm going to change this to 5. We're going to allow everybody on the all-star team. It's that kind of recreational league. So after I've changed this, all I need to do, and of course you could automate all this, but just for the sake of demonstration purposes, you're going to see I just go in here, I compress this, and then I'm going to upload that zip file into S3. So coming back here, S3, when you deploy the quick start, the CloudFormation template creates a bucket for you, and that bucket has a couple of special actual policies that are required for code pipeline. Specifically, server-side encryption. You shouldn't be moving source code up into S3 without things being encrypted at rest. Security best practice, all implemented through the CloudFormation template. So what you see here is both the code pipeline bucket, let's just say prefix, where it's storing all the assets as it moves through the pipeline. And I'll show you the pipeline here in a minute. But first, I want to kick off a deployment. I'm going to upload that zip file that I just showed you. Trust me, that's what's going on. You're going to come back and it's going to be all done. I'm just going to be like, yes. It's time for a new Mac. Are we up? I don't want to look. I'll go back to the slides here in a second if it's going to keep being like this. All right, we'll have to bail. So what you're about to see, and what you can certainly see anytime if you want to go in and actually deploy it yourself, which I highly recommend, is that zip file ends up there. You click release new change via the pipeline. It slurps that in from the S3 bucket, and it processes it through by moving it down. It puts all that code on the Jenkins server, runs the build, puts it into a folder that is considered the publish directory. That then code pipeline will move so that CodeDeploy can push it through. And the beautiful moment is refreshing that page and seeing that 2 more kids made the all-star team. Right, so it's fully automatable. We've walked through it a number of times here, but obviously the technical difficulties are causing us a bit of a challenge. So let me jump back here and find this bad boy. All right, that worked. So as you can see, right, this is sort of how it pushes through. And I didn't get a chance to show you, but on the Jenkins side, when you deploy that job, you choose some things like how frequently am I going to poll to see if there's a build ready to go. And that's what it's doing. It's constantly polling. So there's a little bit of a kind of a non-deterministic aspect to how long that pipeline's going to run, but we're talking minutes here. We're not talking hours, assuming you've configured it in that fashion. And then as far as going across multiple servers, down here, I give you the option to go to 1 or 2 servers, and it really doesn't matter, because it's going to be able to do all that in parallel. And then at the end of the day, you can hit it as a user from an ELB, everything's fully secured, and move forward with it. We really want to see what people are interested in. Go to GitHub, give us some comments. Start asking for different things. If Team City is what you're looking for, then let us know, right? This is a full team of people at AWS that is focused on building better sort of, solutions that are bringing together different services to help you get things to market faster. So, all right, Now, what I want to do is we're going to bring up Theo from Woot, and he's going to talk about their journey, how they've moved from the early phases of starting to work with AWS to what they're doing today, which is far more automated and super powerful and interesting stuff. So, Theo?
Thank you, Tom.
So what is Woot? For those of you who don't know, Woot it actually wasn't a website to begin with. It started with a company that basically wholesaled items. And they would end up with a certain amount of stock that they had a hard time selling, getting rid of, maybe who the other companies they sold to. They're like, that's not enough stock. I'm not going to put in the effort for it. So he ended up talking to his brother and his friends and said, hey, I heard you guys make websites. Can you help me with this? And thus, Woot was born. And Woot is the originator of the deal of a day. So that's like when they started, we sold 1 item a day. It started at midnight central, and however much we had, we sold out. And then you had to wait for the next day. And it became super popular. It became way more popular than the other business. And thus, Woot was born. We actually sell more than one thing now. Customers actually demanded more, but that was how we started. So let's move on to how Woot does DevOps. DevOps is kind of a broad term. A lot of people use it for a lot of different things. And so I wanted to say, what does it mean to Woot? Found this quote from Ernest Mueller. He's running a blog called the Agile Admin. They focus a lot on DevOps. And what we liked about this for Woot is that it talks about more than just deploying things out there. A lot of DevOps is, how do I deploy a image or a piece of hardware fast, right? Well, to us, it's more than that. It's about the full cycle. There's more to an app than just pushing an image out there or pushing a new instance out there. How do you patch it? How do you keep antivirus on it? How do you make a small change and not have to tear down your environment and put it back up? So we think DevOps to us is the total life cycle from start to in production, to running, and then going ahead to decommissioning and improving. The other thing that's important out of that is talking about configuration drift and infrastructure as a code. So what happens a lot of times with these is you push something out, something breaks, you have an emergency fix. Now you've got a configuration drift. You've got 1 server, 2 servers that are different. How do you know that's happening? That could cause catastrophic errors later on. And how you manage that, to us, is making sure your infrastructure is run as code. That means you use your infrastructure code, your PowerShell, you're building all of that, the same way you run, basically, .NET projects. You put it in a repository, you have pipelines, you have automation, and you make it as consistent as possible and as fast as you can to improve it. So this timeline's a little hard to read, but kind of what I wanted to show here is this doesn't happen overnight. A lot of things change along the way. And what we're looking at here is basically the 5 years since Woot started from physical servers going all the way to being in AWS and continuing to use new services as they launch them, finding out there was things we didn't know we wanted, but they built and then they were too cool to ignore. And then also, I wanted to point out that Woot, while we are an Amazon subsidiary, we do exist outside of the firewall. We're not in Amazon corporate. We don't get to use their tools. We don't have any special treatment. We're just like every other customer out there. I don't get special magic just because our parent company is Amazon. I have to face the same problems everyone else does. So we're going to start our journey here, kind of walk through and talk about how it helped, how we innovated about it. 5 years ago, we had physical servers. The installation was manual. Somebody copied a file up. It was a single monolithic project. Deployment was manual. It was a script, but you had to run it. We had a single database server. And out of a lot of this, we had performance and monitoring issues. I mean, even though we had a single one, it wasn't very consistent. It was hard to figure out what was going on. So post-acquisition, and actually right before it, Woot was already building a project in AWS. We had done some competitive analysis, and we basically determined AWS was the place for Woot at the time. I mean, Azure didn't exist, so this is a while ago, ages in the internet land. And what we did is we kind of started to look, we said, what do we want to do? We want to redesign our site. We want to use this new project and new style. How are we going to do it? So we came up with some requirements, and we found how are we going to do this because our scaling and our management is going to drastically change from physical hardware. So we came up with some requirements of we wanted automation. We wanted more redundancy and resiliency. We needed to be able to scale quickly, rapidly, and we needed to improve our security. So what we kind of came up with out of this is we came up with this process of basically, hey, we're going to need a new feature. We're going to need to figure out and make sure that's a good feature through reviewing it. Then we got to build it, deploy it, and execute it. It also had to work for our new SOA design because we wanted to spread out and be more scalable. And what we quickly discovered out of this was that this wasn't going to be possible without automation. As we scaled from one app, one project, if we didn't have automation, we were going to quickly bog down. We couldn't keep doing manual deployments for everything. So what do we do first? Well, Woot is built in .NET, so we had to come up with a deployment pipeline. We had to come up with a way to rapidly provision hardware. At the time, that was PowerShell 2. A couple months after launching it, we quickly went and took up PowerShell 3. The other thing is to move faster. We ended up using a custom AMI. It's called a golden image or a fat image, depending on who you work with. While we didn't like that, at the time, it allowed us to move really fast. The other thing is we identified what are our core things we need out of this. And we had to install our roles for customization. We had to rename and join our domain so we could use domain authentication. We had to be able to install patches and updates. And we got to tell our team when it's ready. This process took about 45 minutes. And one of the things we did here is I want to highlight some of the examples of how we accomplished this. We kind of used a process of how are we going to make this repeatable? It's only a few actions, right? Why spend all the time doing this? But we wanted to build a platform or a framework that we could reuse. So one of this is an example. This is code we actually still use today. We've never had a reason to rip it out. And one of the things we found out is early on, it was really easy for EC2, for the EC2 config service on Windows to think it wants to reboot your machine the next reboot, and it wants to rename it. Nobody wants in a domain situation for your machine every restart to get renamed. So what we did is we wrote a policy here that basically runs and goes ahead and sets the computer name to not be reset on reboot. And we just made sure that that applies every single time. And what you'll notice here that I want to highlight is we made sure we logged it. Right here, we're making sure every action we have is recorded. The other thing we started doing to other items where we don't just always want to tattoo it on there is we make sure we check. Because after a while, when you start building these policies, you don't just want to be making change for change's sake. So what we did here is we make sure we validate that the change has to be put in place. I'm not showing you the whole code, but the idea is we do a validation here, check, and make sure it needs to be installed, and only then log it, and only then perform the action. What we did next is, again, we went and took care of PowerShell 4. Every time a new version comes out, it makes our life so much easier. A lot of stuff that used to take 50, 80 lines of code will take a single commandlet now. The other thing is that code we built the year before that had 5 really key actions, we quickly expanded to 90. We were able to do that because we followed the same processes of making sure it's repeatable, loggable, does validation. The other thing, and I want to highlight this, and we'll talk about it a little bit more, is we built our own security service because we had to pass credentials around. The reason I highlight this is it was a very important point for us, but in a minute, I'm going to tell you, don't ever do this. The other thing we did to help with this is we basically created our own key store. We call it our metadata service. What does that do? We had to be able to assign all these different roles, IIS, Windows services, different settings, and how do we control that? We basically built a key store. You could use Dynamo for this, really easy. You basically just assign different values of, is IIS equals true, IIS authentication equals true, NTLM equals false. And all our code is all parameterized. It'll grab this data and tattoo it on the machine. We also did some efficiency and got our launch down to 35 minutes. A lot of that was actually due to GP2 SSD volumes, which I really thank AWS for. We're so much faster and cheaper than vanilla EBS. The other thing is I want to talk about here that DevOps isn't just about deployment and automation. It's also about choosing technology that helps you. And so that's why I have SQL 2014 on here. Before this, Woot had Windows Server 2008 and SQL Server 2008. Not very cloud friendly. It took us over an hour to do a failover. It was all manual, it was full of risk, it was a bad customer experience. By choosing SQL 2014, putting in the effort, making it automate to deploy, we took our downtime down to less than 30 seconds. We actually have to go offline for 5 just because we have to put up offline pages and we gotta wait for ELB draining, but it fails over in 30 seconds. It's pretty awesome. So don't just focus on your deployment pipeline and automation. Think about what gives the best benefit to your business. I wanna show you how we do our logging too. We still use this today. It was built 4 years ago. We still use it. The reason is it's not broken. It's a little bit, you could use some new commandlet to make it a little bit prettier. But what we're doing here is basically we made a way to automatically set the log and source for every script we run automatically. And so what it does up here is it grabs the script name, stitches it together into our naming scheme, and then it puts it into the application event log on Windows. The other thing you have to do is you have to check. A lot of people don't realize this because it'll silently fail if you don't check it because you can't log if you can't write logs. And what this is you have to be an admin and you have to set the log source as an allowed writer to the event log. And so that's what that's doing down there. It basically goes through and it checks. It says, hey, does this source exist? If not, add it. And then you can see here, we continue our thing of check and see if it fails, and go ahead and report back about it. And then, so where did we go from there? Well, we saw AWS launched a whole lot more services, and we needed to become more efficient. One of the things we did is we started using the AWS AD connector. We used that. It came out before full AD. We used that to go ahead and use AWS Simple Systems Manager, SSM, to join the domain. And what that did is, even though we had our own security service, the last thing we couldn't get rid of was having a set of unencrypted credentials in our scripts to join the domain because we couldn't use our Kerberos security service without having the domain trust. It was kind of a catch-22. So this is where the AWS SSM and connector removed our last security boundary, which really, again, makes us more secure. It's a lot easier to change and rotate that password. The other thing is our scripts that we built reached 109 actions. One of the things about those actions is it takes us less than a day to build one, validate it, push it to staging, and push it to prod. Because we're following the same practice for everything, we know exactly when it fails, we know exactly how to do it, and it's completely repeatable. The other thing is, even though we were putting our logs in the Windows event log, it's really hard to search and find them. So what we did is we used our own custom elk stack, which is Elasticache, Logstash, Kibana. And about a month after we launched that, or 2 months, they actually came out with Amazon's managed Elasticsearch service. Let me tell you, use that. Managing Elasticsearch is not fun. It's not worth the effort unless you're doing something custom with it. The other thing is we replaced our security service with KMS. We use KMS for everything now. The reason is you don't want to own your own crypto. Patching it, making sure it works, securing it is a pain. You don't get a lot of value out of it. While we had to do it in the past, you don't have to do this anymore. KMS makes it dead stupid simple, and you can use IAM roles, so it's pass-through auto-rotated credentials. We also started using AWS CodeDeploy to deploy our infrastructure code. We did that this last summer, and we've averaged more than a deploy a day, which, well, it doesn't seem that much. I have a really small team, There's only a couple of us who actually run the infrastructure code. There's basically 3 of us. And there's weeks at times where we're not actually modifying that. So it just shows how fast we can deploy and automate. The other thing is through efficiency, we got our scripts down to 25 minutes. I wanted to highlight some of our actions here so you can kind of see what we're doing. It's a wide variety of things. We're installing Windows features. We're installing other executables. We're pushing certificates out. We're pushing URL rewrite modules. We're joining AD groups, gzip settings. So through this platform, we can basically do anything. What I want to show you here is the SSM domain name and name change. And so what this does here is through user data, we go ahead and push rename before we go ahead and assign our SSM association, which then joins the domain. I'm starting to run out of time, so I'm going to skip past some of this here. So what's next? This year, we're going to get rid of our custom image, again, for security and speed. We're going to start switching all our code to DSC. The reason is it provides a lot of the framework that we had to build ourselves. It's going to make us faster. We're going to switch our applications to CodeDeploy. We're also going to integrate code pipeline, which Tom was talking about. The other thing is, again, on the DevOps process of looking outside the box, is we're using a lot more serverless services where it makes sense. For instance, we used to have servers that just ran cron jobs for us or scheduled tasks. And instead, we switched to using Lambda. We no longer have to manage and patch those instances. It's just super cheap and super easy. We're also going to look for immutable infrastructure for large changes. And with these, we want to get our launch time down to 10 minutes or less, which in Windows land is ridiculously fast. It's not as fast as Linux, but Windows has a lot bigger hard drives, a lot more mechanics going on. I wanted to thank you guys for coming. We hope you enjoyed it. We have some Woot monkeys for everybody. If you take a Woot monkey, you have to give us a 5 for this talk. It's a contract.
And launch the quick start.
If you take a monkey and you give us a 1, we will find you, and I will make sure you don't get a bag of crap the next time you order it. We got one other thing. We kind of ran out of time, but we will be up here to do Q&A if you have any questions.
Yep.
The other thing, don't forget to do your evaluations. It's really important to us and AWS to make sure we're providing you value and how to improve next year.
Come grab a monkey.
With that, come on up and grab some Woot monkeys.